Hello everyone, here are the solutions to 1 through 4, but I want to talk about each part of the question as well as show you the graph on Desmos. Now for part A, when we're asked what is the most number of peaks or valleys or the extrema that we would expect, recall the extrema to expect, max number, is equal to the degree minus 1. So in number 1, the degree is 3, so 3 minus 1 will give us 2. So we would expect 2 relative extrema at the most. Question B, what is the total number of complex zeros that we would expect? That matches the degree, so that's where it's 3. Now for C, we want to actually graph this. So here's the graph to number 1. And I put in the window settings. Remember, you can always go to this tool icon, and then this is where on the x-axis and the y-axis you can graph those. So what we're looking at here for the zeros is a negative 0.64, 1.135, and 5.505. And then D, how many of the zeros of the function will be imaginary? Well, we would expect 3 complex zeros. We got 3 real zeros. So what we have listed here, these are the real zeros. So the number of complex zeros minus the number of real zeros lead us to imaginary. So 3 minus 3 would just leave us with 0. All right, for number 2, the max number of extrema is going to be the degree 3 minus 1 is 2. For B, the total number of complex zeros is the degree. Let's take a look at this graph. So we're looking at the zeros of negative 0.646, a 2, and a 4.646. And again, we have 3 real zeros, 3 complex zeros is to be expected, so no imaginary zeros. Looking at 3, the degree is 4, so the max number of relative extrema to expect is 4 minus 1, which is 3. Total number of complex zeros would be 4. And we get all 4 real zeros here. These are nice integer values, so let's take a look here. There's negative 4, negative 1, 1, and 2. So we had 4 complex zeros total, 4 real zeros, so no imaginary zeros. Now number 4 is actually the example we did in class yesterday, but to specifically answer parts A and B, total number of relative extrema to expect, max number here is 5 minus 1, which is 4. B, total number of complex zeros matches the degree. Here we have 3 real zeros. So if we're expecting 5 complex zeros, we get 3 real. That means we have to have 2 imaginary. All right, so next we're going to take a look at number 5 off of yesterday's worksheet. So before I have you graph this on Desmos, so we can answer part A without looking at the graph. What is the most number of peaks or valleys you expect in the graph of the function? So remember, they're asking for the most number, the max number of relative extrema. So we answer this by saying the degree minus 1. Our degree is 3 minus 1, so we should expect 2. Now just to show you, anytime we have, this is what we call a cubic function. The general shape of a cubic function is to go up, come down, and go back up again. So if our graph were crossing the x-axis, it would cross a total of 3 times. So for it to go up and then turn back down, it has to turn once, and it has to turn twice. So that's why it's the degree minus 1. So B, find all relative extrema, local extrema is what we also call it, and state where they occur. So this is what we practiced yesterday. So go ahead to Desmos and graph this function. Pause the video to do that. Now, it still may come out nice. If you could see all of the important points on the graph, you don't need to adjust it, but this is here to help just in case you don't. On Desmos, we could see a bigger window. On the Inspire calculators, I usually had this set up because it was a smaller window setting by default. All right, so pause again if you still need more time. Let's take a look at this graph. All right, so again, for part B, find all relative extrema. So we have to be careful here. We do have a low point right here, very easy to see. So we need that ordered pair to help us out. Now at the very top, you might see 2 gray points. to point this out, the peak is just a little bit to the left of the y-axis. So I'm going to put both points up here, and we're going to talk about that. The relative max is at this ordered pair that's off to the left. We call this is the y-axis, so the 0, 6 is actually the y-intercept, and we're going to need that for part C. All right, so let's take a look at the relative max. We want to write this out as a statement. I do not want to see ordered pairs. So we only have one of each. If we happen to have two peaks or two relative maxes, we would write out a statement for each max and each min that we have. So we would say the relative max is, and that y value of that point was 6.041. So we're looking at the y value here. So the relative max is y equals 6.041 when x is equal to negative 0.082. And then if we go over to our min, we're going to say our relative min is this negative 30.041 when x is 4.082. But these are the statements, so it's not hard to remember. The graph is, Desmos is doing all the work for you. So we want to state the coordinates of the y-intercept. So when it's actually asking for coordinates, yes, it would be 0, 6. But if I just asked you for the y-intercept, it would be 6. Now there's two ways to do this. Graphically is one of them, or if we go back to our function, y is equal to x cubed minus 6x squared minus x plus 6. Remember, x is 0 when we're looking at the y-intercept. So if we did all of these values for 0, we would get 0, 0, 0 here, and we would just be left with 6. So this gives us that y is equal to 6. So that's our y-intercept of 6, or the coordinate of 0, 6. All right, next what I want to take a look at is the difference between a single real 0 and a double real 0. So we're just going to make a little sketch here. And I want you to think about them, hopefully what you can remember from last year. I'm going to draw something that looks like this. And I'm going to put a point here, and I'm going to put a point here. So that might help you remember. Which of these, I'll call this x equals a and x equals b, what would be the single 0? What would be the double 0? A single real 0 is going to actually cross the x-axis. So this would be a single 0. A double real 0 just sort of sits, or what we like to say, touches and turns on x-axis. So this would be a double 0. Now imagine if this were any lower, it would go through the x-axis twice. That's why we call it a double. But this is what's going to happen eventually, what we're going to look at tomorrow, what it means to see the equation factored. So now you can finish yesterday's worksheet. Make sure you read the directions carefully for each part. But 6, 7, 8, and 9, you're using Desmos and the information from today's lesson and yesterday's lesson to help you answer. And on 10 and 11, you're looking at a graph and you're indicating which points match what you're being asked to kind of match there, to write out or identify. Go back and retry 1 through 4 if you need to. Let me know if you have any questions.